Problem 11, we're supposed to do this addition problem in base 7 and write the answer in base 7. Every single digit we write should be the answer to a base 7 problem. So in base 7 we can use the numbers digits 0 through 6. And so we add a 4 and a 3. This is a regular 4 and a 3. It's 4 ones and 3 ones. That's 7 ones. But we certainly don't put 7. Instead, we come to our base 7 chart, and 7 will be 1, 0. So we put the 0 down, we carry the 1. We add 1 and 5 and 6. That's 6 and 6. That's 12. But we certainly don't write down 12. 12 is a base 10 result. We need 12 written here with base 7. It won't be 2 of these 7s. It'll be 1 of these 7s and 5 1s. 1 7 plus 5 1s is 12. So we write down the 5, we carry the 1. And now we're getting an 11. So now we need an 11, which is a base 10 number. We need to write it in base 7. It'll have 1, 7, and 4 1s. And so we have in problem 11 that the result of the addition is 1450 in base 7. We could check this if we wanted to by rewriting all of these numbers in base 10 and see if the base 10 quantity works out. So let's do that. We have 6 times 49 plus 5 times 7 plus 4 times 1. That's the 654 number. This would be 294 plus 35 plus 4, which is 294 plus 39, which is 333. Now we have the 463 number. And the 463 number is 4 times 49 plus 6 times 7 plus 3 times 1. 4 times 49 is 196 plus 42 plus 3, that's 45, being added on to 196. That's 241. When we add those, we get 475. So the question is that 574? So we have turning 1450. That'd be 1 of these 7 to the 3rd powers. That's 343 plus 4 times 49 plus 5 times 7 plus 0 ones. This is 35, this is 49 times 4, which is 196, and this is 343, so we have 343, 196, and 35, 94171, so we have 574. Check. So you can always check one of these additions in a different base by turning things into base 10. And with a calculator, that'd go fairly quickly. Here we're doing a subtraction in base 3. We want a base 3 answer. We can't do 1 take away 2 without going to negative numbers, so we borrow 1 from here and put the 1 here. But the thing is, when you're writing stuff in this problem, you're writing it in base 3, even if you're thinking base 10. So this 1, 1 is in base 3. What is 1, 1 in base 3? Well, it's 1, 3 and 1, 1. That's 3 plus 1, that's 4. So this is 4 take away 2, which is 2. Now we have 1 take away 0, which is 1, 2 take away 2, which is 0, 1 take away 0, which is 1. And so we're getting 1, 0, 1, 2 in base 3. This would check if we wanted to. We could turn each of these original numbers into base 10 and then do the subtraction in base 10 and see if it works. I'll leave the checking up to you on this problem. We're going to do this multiplication in base 8. We have 1 times 7 being 7, which is 7 in base 8. It's 7 in base 10, so we're good. 1 times 3 is 3. So far we haven't encountered any difficulties at all. Just like multiplication with base 10, we put a little mark here, or leave a 0 here, or leave it blank, either one. And then we start this second row of multiplication. Now 2 times 7 is 14, but 14 is a base 10 number. We're not going to write down a 14. Instead, we're going to come over here and try to figure out what the heck 14 is. 14 is one of these 8s and 6 of these 1s. So 14 in base 10 is 1 6 in base 8, and we need the 1 6. We're writing stuff in base 8. So we're going to put down the 6, and then we're going to carry the little 1. And so we have 2 times 3 is 6, plus the 1 we carried is 7. Now we add, we get 7. Here we add and we get 9, but we can't write down 9 because that's a base 10 number. So we turn 9 into base 8. It's 1 8 and 1 1. So that 9 is 1. Carry the 1. And I guess we could put the 1 right there. And we have 1 plus 7, which is 8. But we can't write down 8 in base 8. So we need to figure out what 8 is. It's 1 0. So we have this 1 0 1 7 number, and that number is in base 8. So this was our last class meeting for some of you on Thursday night, 10/17. Which has nothing to do with anything. Also, you could turn this into a base 10 number, and this into a base 10 number, and this into a base 10 number, and see if this times this equaled this. That would check. I recommend checking. Division's trickier. It's trickier in base 10, it's trickier in base 5, it's trickier in all the bases. Division is most likely the hardest kind of arithmetic that we teach. Do you see what's wrong with saying that this is 3 into 22? This is not 22, it's 2 base 5 is what it is. It's not 22 base 10, so it's not going in 7 times. It's 2 base 5, so I made a base 5 chart here, and what does 2 equal? It equals 2 5s plus 2 1s. That's 10 plus 2, that's 12. So this 2 is really 12. How many times does 3 go into 12? Well, it goes in exactly 4 times. Now we're supposed to do this multiplication. 4 times 3 is 12, but we're supposed to write the 12 in base 5. Everything you write here should be base 5. Well, how do you write 12 in base 5? Well, it's 2. That's all very strange. So we subtract and get 0. We bring down the next number. How many times does 3 go into 4? Well, just once. And we subtract and we get a remainder 1. So in base 5, the answer to 3 into 224 is 4 1 base 5, remainder 1 base 5. Now the remainder 1 is a remainder 1 no matter what base you're in, so that last 5 isn't probably strictly speaking necessary, but it's still a good idea to get used to. We can check these by turning these numbers into base 10 and seeing what we have. So this number in base 10 is 3. This number in base 10, let's see what it would be. It's a 2, 2, 4. This is 50. Plus 10 is 60 plus 4, so this is 64. The 41 up top, the 4 1, is 4 times 5 is 20, plus 1 times 1, that'd be 21. And 1 is 1. So if we turn all these numbers into base 10 numbers, we get 3 into 64 goes 21 times remainder 1. That's a check. So that's kind of proof that we've done this correctly.